Welcome to Achievers Academy. Today we are going to be dealing on integration using substitution method. Now, what do you understand about the idea of integration using substitution method? In my previous video, we talked about integration using general method. So please, I want you to know that there are some questions that they are going to give you, are going to meet that using general method cannot solve the solution. So the next thing you do was by what? By substitution method. So now let's look at this example. So when you evaluate integral of what? S over square root of 1 minus s raised to power 4 dx. You have to evaluate what? Square root of what? Integral of s over 1 over square root of 1 minus s raised to power 4 dx. Now, how are you going to do it? Please, I want you to take note of this. Let me do a simple trick on the board. When you have s raised to power 4, please, s raised to power 4 can simply be written as what? As s raised to power 2, close the bracket, raised to power 2. Yes or no? Yes. Because in indices form, when you have a raised to power b or square, can also be written as what? A raised to power b s. Is that also? So please, I'm going to transfer this trick method, s raised to power 4, into this simplest form method. So now I'm going to have integral of s over square root of 1 minus s raised to power 2 or square dx. Now, what is the next thing? The next thing is what? I'm going to make u. Please take note of, we are dealing with substitution method. So whenever you see s, this is s squared. And listen to me now. So I can differentiate s squared. So you said let u is equal to what? Is equal to s squared. So if u is equal to s squared, if you differentiate u, please take note that in my previous video I said integration is simply the reverse of differentiation. So now, if you differentiate u, you are going to have du ds is equal to what? 2s. Is that not so? Which is going to be du over ds is equal to what? 2s. Now, what is this? This is ds. Please, I want to make ds as subject of formula. 2s is the subject of formula, but I want to make ds as subject of formula to represent this form. So what are you going to do? You cross multiply. So if you cross multiply, you are going to have what? ds is equal to what? Is equal to du over what? Over 2s. I believe you all know that. Take note of this. So whenever you see ds, it's going to represent what? Du over what? Over 2s. So now we come back to our question, which is going to be integral of what? Of s over square root of what? Square root of 1 minus, please, what is my s square? My s square is what? U, which is going to be what? U squared. Is that also? Let u represent what? S squared. So whenever you see s squared, what are you going to put there? U raised to power what? 2. Are you there? So multiply by what? Multiply by what? Du over 2s. Now, this is the simplest form. S eliminates s. Is that not so? So if s eliminates s, what are you having? You are having integral of what? So you are going to have what? Integral of what? Du over what? Over square root of what? Square root of 1 minus u squared multiplied by what? 1 over 2. Is that not so? Yes. So now, this is, if I to take this one out, I'm going to have something like this, which is going to be equal to what? 1 over 2. Is that not so? Integral of what? Integral of what? Du over square root of what? Over square root of 1 minus what? U squared. And please, if you look at the board, I told you in my previous video that integration, you have to follow some method, some rules in integration. So there's a rule in integration that whenever you have square root of a minus s squared is going to be equal to arcsine raised to power what? Raised to power a over s. Please, this is just the rules. Please take note of these rules. Whenever you have square root of a, now what is my a? My a is a constant, which is 1 from the question, minus s raised to power what? 4, which is s raised to power 2 all square. And you do to me now. So the rule said that whenever you have this kind of this, it's going to simply breaking down into sine inverse of what? Sine inverse of a over s plus c. I did it to me now. So I'm going to transfer this form into this. I did it to me now. So which is going to be equal to what? So you are going to have into s over a. So now I'm going to take this form into back to this process. You can see that this and this, they're also the same thing. So you are going to have 1 over 2, which is going to be 1 over 2 integral of du over square root of what? 1 minus u squared is going to be equal to what? 1. So which is going to be arcsine inverse of what? Of u plus what? Plus c. Are you there now? So arcsine inverse of u plus c. Are you listening to me? So this is the form. The law said that whenever you have square root of a minus s squared, is going to simply means sine inverse of what? Of s over 8 plus c. Now, if you, let me take it, if you differentiate arcsine, if you differentiate arcsine, those of you that you are following my video, you can see that you are going to have something like this. If you differentiate arcsine, so whenever, that's why we say integration is simply the reverse of differentiation. So if you differentiate sine, arcsine in differentiation, you are going to have this. But integration, if you integrate a minus s squared, which is simply as what? 1 minus u squared, you are going to have what? Arcsine inverse of what? X over a. But in this place, my s is known as what? U. And listen to me now. So which is going to be equal to 1 over 2 arcsine inverse. What is u? U is what? S squared, which is going to be s squared plus c. So that is your answer. So let's look at example 2. So example 2, evaluate integral of exponential s over 1 plus exponential 2s dx. Please take note, we are dealing with integration. I always say this as integration is simply the reverse of differentiation. Now, please, if you differentiate, if you look at this type of form of this question, if you don't know the rules and steps we follow in integration, you can't understand this question. That is why there is a method of rules and regulations that was formed into the screen. Now, please look at it very well. You are going to take it attached to each other. So you must know the one that's equal to this. Are you listening to me now? So now, if you integrate, please take note. In differentiation, the examples I did, I said y is equal to arctan. Arctan of what? Arctan of s. If you differentiate tan, please take note. If you differentiate tan, arctan, if you differentiate arctan, which is inverse of tan, you are going to have 1 over 1 plus s squared. I listen to me now. If you differentiate at tan, you are going to have 1 over 1 plus s squared. I listen to me. So now that's why we said integration is simply the reverse of differentiation. If you differentiate y and you get s, now if you integrate s, you are going to have y. Please take note of that. Integration is. So now let's go back to this example. Y is integral of exponential s over 1 plus exponential 2s dx. So which is going to be equal to exponential what? Exponential s over 1 plus exponential 2s dx. Please, I want to make the s a subject of formula. I believe you know that. So now, what am I going to do here? I can simply write this form in form of what? Exponential integral of exponential s over 1 plus exponential s all square. Is that not so? Yes, I'm right. Exponential s, I can write it as 2, s raised to power 2 is equal to exponential 2s. They are also the same thing. So now, let u is equal to what? Exponential s. So if u is equal to exponential s, and don't forget something about exponential method. If you differentiate exponential method, you are going to get exponential. So differentiation of du over ds is going to be what? Exponential s. So I want to make ds a subject of formula. So ds is going to be equal to what? Du over what? Over exponential s. So now once you make the s a subject of formula, you can come back to this question, ds. So which is going to be equal to exponential what? Exponential s over 1 plus, what is my exponential s class, please, which is u raised to power 2 multiplied by, what is ds? ds is what? Du over exponential s. So exponential s eliminate exponential s. Is that not so? So what are you having? You are having what? You are having du integral of du over what? Over 1 plus u squared. So please take note in form of this. When you have question like this, using the rules and regulation of constants of integration, it says that when you have 1 over 1 plus s squared, but here I'm having as u squared. Let me make it as u squared. It's going to be equal to arctan inverse of u over c, u over 1 plus c. Please take note of that. If you're having 1 over 1 plus u squared, is going to be the inverse of arctan. So now I can simply say that the form of this can also be written like this. Please take note of that. So which is going to be equal to tan arctan into u plus c. So what is u? U is what? Exponential s. So the final answer is going to be tan inverse of what? Inverse of exponential s plus c. So that is your final answer. So please, whenever you see question based on substitution method, the first thing you are going to do is you go back to the rules using integration method. You are going to look which one is also almost the same thing like this. And listen to me now. So one is almost the same thing. The next step, you take what? Whenever you give s raised to power 2, you take that 2 outside using this method and you differentiate. Once you differentiate, if you differentiate, you must differentiate in substitution method because you want to make the s a subject of formula. So once you differentiate, you make the s a subject of formula, you are going to have du all over what you have. So you input it in ds and you cross multiply and you arrive to your final answer. So please, I want you to like, share, and comment to this YouTube channel. Thank you so much.